So now that you've had a chance to see the common fork join pool in action and see how you can use manage blocker and so on, let's summarize some of the benefits of using the common fork join pool. So there's a number of things that you get, and these are what make it very valuable. And it's probably a good idea to try to use it as much as you can for the reasons we're about to discuss. The comparison and contrasting I'm going to be doing here is with other Java thread pools that you get kind of out of the box. So as you can see here, we have the common fork join pool, but then there's also the cached variable size thread pools, there's the fixed size thread pools, and of course there's also the non-common fork join thread pools as well. So there's a number of different comparisons. So one benefit of using the common fork join pool, and this is really more of a reason for using the fork join pool, is to get this locality of reference feature. And where that comes from is from the way in which the fork join pool is optimized internally, where you have this pool of threads. These are Java worker threads, the real Java threads, the so-called system threads, and as opposed to virtual threads, these are the platform threads. And basically, each of those threads has its own little double-ended queue, its own deck, and therefore, for the most part, you get very good locality of reference because the thread that puts the work onto the work queue is often, though not always, the thread that pops the work off and then performs the computation. Another nice thing, and again, this is just the benefit of using fork join pool as opposed to other pools, is you get recursive decomposition. And the typical way you use the fork join pool mechanism, and I'll show you this when we look at some examples here shortly in more detail. Usually the way you do it is you start out with all the work to be done, and then you subdivide it into a couple of chunks, and you push those chunks onto the deck, onto the top of the deck. And then you get some other work, and then you pop the top item off, and then you further decompose it into smaller chunks, and you push that onto the front or the head of the deck. And this keeps happening, and so what'll happen is the stuff that's at the front of the deck are the smaller tasks, and the things that are larger are towards the back of the deck. And that's very important, that particular characteristic of putting bigger things end up at the back or the tail of the deck as opposed to the head of the deck. That's very important because of the work stealing mechanism. And what happens is whenever a thread runs out of tasks to work on, it's going to go and steal tasks from the end of another thread's deck. And because what it gets at the end of the other thread's deck are the bigger chunks, it can then start that whole process over again of recursively decomposing the big things into smaller things. So the long and the short of it is you're typically stealing large chunks of work and then splitting them into smaller chunks of work. And you're typically working on smaller chunks of work. So that basically allows more utilization of the underlying processor core and also splitting things up into progressively smaller chunks, which again benefits by keeping the processors and the processor cores humming along nicely. Now we finally get into something that's really the common fork join pool benefit, which is optimized resource utilization. And that's because that common pool can be aware of which cores are used globally within a process. So I always think of Professor X from the X-Men with Cerebro, and he's got this little thing and he can see everybody in the world, and he's got sort of a global view of what's happening in the world. And that's kind of the way that the common fork join pool works. Another thing that the common fork join pool gives you is auto-scaling via the manage blocker interface that we talked about, which can be used to temporarily add worker threads to the common fork join pool. So just a quick summary of benefits of the common fork join pool and fork join pool in general. So there's really two parts to that. I will rearrange this for future classes to make it more clear what's the fork join pool benefits, which really have to do with the locality of reference and really have to do with the issues related to recursive decomposition and work stealing. That's the fork join pools part. And then there's the common fork join pool, which is that global perspective of things.